Each isolated ground circuit, also known as IGC, must have its own dedicated isolated ground conductor extending back to the panel. The fundamental purpose of an isolated ground circuit is to create a separate ground path for sensitive electronic equipment, effectively isolating it from the building or facility's primary grounding system. This isolation is crucial for preventing ground loops and mitigating the introduction of electrical noise, both of which can significantly disrupt the reliable operation of sensitive equipment. If multiple devices are inadvertently connected to a single isolated ground circuit, the cumulative ground current originating from all connected devices will be forced to flow through a shared ground conductor. This configuration introduces the potential for a ground loop to form. A ground loop arises when there are multiple paths for current to flow to ground, creating a circulating current that can manifest as electrical noise and interference, negatively impacting the performance of the connected equipment. To mitigate the risk of ground loops and ensure optimal performance, each isolated ground circuit must maintain its own dedicated isolated ground conductor that extends all the way back to the electrical panel. This dedicated conductor ensures that the ground current from each device remains isolated, preventing the mixing of ground currents that can lead to unwanted noise and interference. Here's a more detailed breakdown of why dedicated isolated ground conductors are essential. Firstly, preventing ground loops is paramount. A ground loop occurs when multiple paths to ground exist, creating a loop in the grounding system. This loop can act as an antenna, picking up electromagnetic interference and introducing noise into the sensitive equipment connected to the isolated ground. By using a dedicated isolated ground conductor for each circuit, you eliminate the possibility of creating ground loops. Secondly, minimizing electrical noise is crucial. Sensitive electronic equipment is susceptible to electrical noise, which can disrupt its operation and cause data errors. Electrical noise can originate from various sources, including nearby equipment, power lines, and radio frequency interference. An isolated ground helps to minimize electrical noise by providing a clean, dedicated path to ground for the sensitive equipment. Thirdly, ensuring proper grounding is vital for safety. A properly grounded electrical system is essential for protecting people and equipment from electrical shock and fire hazard. An isolated ground provides an additional layer of safety by ensuring that the sensitive equipment is properly grounded, even if there are faults in the building's main grounding system. To further clarify, consider the implications of sharing an isolated ground conductor. If several IT switches are connected to a single isolated ground conductor, any noise generated by one switch will be coupled to all the other switches in the same circuit. This can lead to data corruption, network instability, and even equipment damage. By providing each switch with its own dedicated isolated ground conductor, you prevent this noise coupling and ensure that each device operates in a clean electrical environment. Let's discuss some practical considerations for installing isolated ground circuits. When installing isolated ground circuits, it's crucial to follow all applicable electrical codes and standards, such as the National Electrical Code, also known as NEC. The NEC provides specific requirements for isolated ground circuits, including the size and type of conductor to use, the method of installation, and the labeling requirements. Be sure to consult the latest edition of the NEC for the most up-to-date information. When running the isolated ground conductor back to the panel, it's essential to keep it separate from the other grounding conductors in the building. This can be accomplished by running the isolated ground conductor in its own conduit or cable tray. Avoid bundling the isolated ground conductor with other grounding conductors, as this can introduce noise and interference. Properly labeling the isolated ground circuits is crucial for identification. Clearly label each receptacle and the corresponding circuit breaker in the panel to indicate that it is an isolated ground circuit. This will help prevent accidental connections to the wrong circuit and ensure that maintenance personnel are aware of the special grounding requirements. Here are some additional points to consider. Firstly, use high-quality components for the isolated ground circuits, including receptacles, conductors, and circuit breakers. This will help ensure that the circuit performs reliably and provides the necessary level of isolation. Secondly, test the isolated ground circuits after installation to verify that they are functioning correctly. Use a ground loop tester to measure the impedance of the ground path and ensure that it is within the acceptable limits. Thirdly, regularly inspect the isolated ground circuits for any signs of damage or deterioration. Check the receptacles for loose connections and the conductors for any signs of wear or corrosion. Replace any damaged components immediately to maintain the integrity of the isolated ground circuits. Let's delve into some common misconceptions about isolated ground circuits. One common misconception is that isolated ground circuits are only necessary for highly sensitive equipment, such as medical devices or scientific instruments. While it's true that these types of equipment often require isolated ground circuits, they can also be beneficial for a wide range of other electronic devices, including computers, servers, and network equipment. Another misconception is that isolated ground circuits are a substitute for proper grounding. Isolated ground circuits are an addition to the building's main grounding system, not a replacement for it. The building's main grounding system is still necessary to provide a safe path for fault current to flow in the event of an electrical fault. By using isolated ground circuits in conjunction with a properly installed grounding system, you can provide the best possible protection for your sensitive electronic equipment. To further clarify the concept of ground loops, consider the following scenario. Imagine that you have two pieces of equipment that are both connected to the same electrical panel. Each piece of equipment has its own ground connection, and both ground connections are tied back to the panel. If there is a voltage difference between the two ground connections, a current will flow through the ground loop, creating noise and interference. This voltage difference can be caused by a variety of factors, including differences in ground potential, electromagnetic interference, and even the flow of current through the building's grounding system. By isolating the ground connections of the two pieces of equipment, you can prevent the formation of a ground loop and eliminate the noise and interference. In conclusion, isolated ground circuits play a crucial role in protecting sensitive electronic equipment from electrical noise and interference. By using dedicated isolated ground conductors for each circuit, you can prevent ground loops and ensure that each device operates in a clean electrical environment. Remember to follow all applicable electrical codes and standards, use high-quality components, and test the circuits after installation to verify that they are functioning correctly. By taking these precautions, you can ensure that your sensitive equipment is properly protected and operates reliably. Here's a summary of the key points to remember. Firstly, isolated ground circuits require dedicated isolated ground conductors. Secondly, sharing isolated ground conductors can create ground loops. Thirdly, ground loops can introduce electrical noise and interference. Fourthly, electrical noise can disrupt the operation of sensitive equipment. Fifthly, follow all applicable electrical codes and standards. Sixthly, use high-quality components. Seventhly, test the circuits after installation. Eighthly, regularly inspect the circuits for damage. Ninthly, isolated ground circuits are an addition to the building's main grounding system. And tenthly, isolated ground circuits are beneficial for a wide range of electronic devices. Let's also touch upon the impact of improper isolated ground circuit installation. An improperly installed isolated ground circuit can be worse than no isolated ground circuit at all. If the isolated ground conductor is not properly isolated from the building's main grounding system, it can actually create a larger ground loop, exacerbating the noise and interference problems. Therefore, it's crucial to follow all applicable electrical codes and standards and to use qualified electricians who are experienced in installing isolated ground circuits. Another important consideration is the size of the isolated ground conductor. The NEC specifies the minimum size of the isolated ground conductor based on the size of the circuit conductors. It's important to use the correct size conductor to ensure that it can safely carry the fault current in the event of an electrical fault. Using an undersized conductor can create a fire hazard. Furthermore, the type of conductor used for the isolated ground is also important. The NEC requires that the isolated ground conductor be insulated to prevent it from coming into contact with other metal objects. This insulation helps to maintain the isolation of the ground path and prevent the introduction of noise and interference. In addition to the technical aspects of isolated ground circuits, it's also important to consider the human factors. Clearly communicate the purpose and requirements of isolated ground circuits to all personnel who work with the electrical system. This will help prevent accidental connections to the wrong circuits and ensure that everyone understands the importance of maintaining the integrity of the isolated ground circuits. Let's now discuss some of the tools and equipment that are used to install and test isolated ground circuits. A ground loop tester is an essential tool for verifying that the isolated ground is functioning correctly. This tester measures the impedance of the ground path and can detect the presence of ground loops. A multimeter is also a valuable tool for measuring voltage and current in the isolated ground circuits. This can help identify potential problems such as excessive voltage drop or ground current. A wire stripper is used to remove the insulation from the conductors without damaging the wire. A crimping tool is used to attach connectors to the conductors, creating a secure, reliable connection. A labeling machine is used to create clear and durable labels for the receptacles and circuit breakers. Finally, let's consider some of the future trends in isolated ground circuit technology. As electronic equipment becomes more sensitive and sophisticated, the demand for isolated ground circuits is likely to increase. New technologies are being developed to improve the performance and reliability of isolated ground circuits. For example, some manufacturers are developing active isolated ground circuits that use electronic components to actively cancel out noise and interference. Other manufacturers are developing wireless isolated ground circuits that eliminate the need for physical conductors. These new technologies have the potential to significantly improve the performance of sensitive electronic equipment and to reduce the cost and complexity of installing isolated ground circuits. In summary, the proper installation and maintenance of isolated ground circuits are essential for protecting sensitive electronic equipment from electrical noise and interference. By following all applicable electrical codes and standards, using high-quality components, and testing the circuits after installation, you can ensure that your equipment operates reliably and that your electrical system is safe. Remember to consult with qualified electricians who are experienced in installing isolated ground circuits to ensure that the job is done correctly.